If you've been feeling like the ground is constantly shifting beneath your feet in the world of artificial intelligence right now, trust me, you are definitely not alone. Welcome to This Explainer. Today, we're taking the latest intelligence dossier and transforming it into a definitive, cinematic map of the June 2026 AI landscape. We're cutting through all the marketing hype to give you a serious, structured look at what this ecosystem actually looks like today. Now, to do that, let's just make sure we're on the exact same page. We've evolved rapidly from broad artificial intelligence into targeted machine learning, which gave us the deep learning neural networks that eventually unlocked the massive foundation models driving all of today's generative AI. So let's dive right in by confronting what is literally the most common question I hear. From curious students all the way up to enterprise developers, everybody is asking, what is the best AI model? I mean, it seems like a straightforward question, right? You just want to know where to invest your time and your money. Well, spoiler alert for 2026. There isn't one. The whole idea of monolithic dominance by one single all-powerful model, yeah, that's officially shattered. It's been completely replaced by this hyper-competitive landscape driven by highly specialized tasks and massive, massive cost compression. The gap between the absolute top models is narrower than ever. So the real question is no longer which model is best. Actually, it's which model is best for this specific task, at this specific cost, with this latency, and with what strategic risk. So here is our map for today. 1. Mapping the ecosystem. 2. The frontier race. 3. The open weight revolution. 4. Separating benchmarks from reality. And 5. The 2026 playbook. Let's start with part 1, mapping the ecosystem. To truly grasp the lay of the land, we have to look under the hood of these foundation models, specifically at a structural mechanic called mixture of experts, or MOE. You see, dense transformers, where literally every parameter is used for every single word, have been largely abandoned at the frontier. Instead, we use MOE. Think of it like having a massive team of thousands of specialists on staff, but only waking up the exact 2 people needed for a highly specific question. It saves a ton of compute power. For example, DeepSeek v4 has a staggering 1.6 trillion parameters, but only 49 billion are active at any given time. It gives you this massive knowledge capacity without a proportional explosion in cost. And that brings us to, honestly, the biggest structural shift of 2026, agentic systems. We are rapidly moving away from simple back-and-forth chat models. An agentic system wraps a model in scaffolding that allows it to actually take action. It can browse the web, write code, run tests, and iterate on its own. The AI is no longer just a conversationalist. It is an autonomous actor. To put that into perspective, Gartner estimates that 40% of all enterprise applications will embed AI agents by mid-2026. Now, I also need to clear up a huge misconception here that trips up a lot of startups. True open source, where the training data and the code are fully public for anyone to see, is incredibly rare in frontier AI. What we actually have today is an open weight ecosystem. That means you can download the trained model and run it locally on your own hardware, but you don't own the underlying training data, and you often don't have unlimited commercial freedom. Meta's Llama 4, for instance, caps commercial use if you have over 700 million users. All right, moving to part 2, the frontier race. Right now, the absolute cutting edge of AI is locked in this intense 4-way tie. You've got Anthropic's Claude Opus 4.8, which is the undisputed leader for long-form writing and complex coding agents. Then there's OpenAI's GPT 5.5, which is just an absolute powerhouse, all-around ecosystem player with deep multimodal capabilities. Google's Gemini 3.1 Pro is the speed demon of the group, boasting 129 tokens a second with really tight Google Workspace integration. And finally, xAI's Grok 4.3 leverages a massive 2 million token context window alongside real-time Twitter data. Oh, and notice that reasoning mode, the ability to have the model spend extra compute thinking before it answers you. That is now just a standard dial. You turn on all of these, not a separate product category anymore. But, peel back the software layer and the physical reality underneath is honestly kind of fragile. NVIDIA still holds an estimated 80% of the AI training GPU market. This makes hardware supply chains an almost absurd geopolitical vulnerability for every single lab out there. For instance, the April 2026 H20 chip ban forced a massive write-down and really accelerated global fragmentation, pushing regions like China to build entirely autonomous sovereignty stacks. So making a strategic AI choice today involves immense vendor and geopolitical risk, not just looking at raw capability. Which brings us to part 3, the open weight revolution. While the frontier labs are pouring billions into compute, there's a second, parallel revolution happening that has completely disrupted the economics of the field. open-weight systems have achieved genuine parity with the closed frontier. Labs like DeepSeek, Meta, and Alibaba are releasing models you can literally host on your own servers. Llama 4 Scout features an unbelievable 10 million token context window. Alibaba's Qwen 3.6 is a multilingual powerhouse, and DeepSeek V4 Pro, released under an incredibly permissive MIT license, is straight up matching or beating top Western models on coding benchmarks. What does this actually mean for you? Basically, the old enterprise assumption that you just have to pay for a closed API to get top-tier results, that's dead. Because open-weight systems like DeepSeek V4 Pro now match models like GPT 5.5 on coding tasks, sometimes at a fraction of the cost. The always-use closed frontier default is no longer economically or qualitatively justified. Plus, you can host these yourself, keeping all your data entirely private. Part 4. Benchmarks and reality. So how do we actually know these models are matched? Well, to measure intelligence, we traditionally use benchmarks. But classic benchmarks like the MMLU, which tests general knowledge, are completely saturated right now. Everyone scores near 100%. It's like giving a college exam to a room full of postdocs. It tells us nothing. This has forced serious evaluators to rely on brutal new tests like Humanities Last Exam, or HLE, which is designed by experts to be incredibly difficult. On those tests, top models are only scoring around 65%. If you're seriously evaluating models today, you have to look at the hard tests like HLE or SWE Bench for coding to separate the marketing hype from reality. And at the exact same time we are measuring this rising intelligence, we've witnessed a radical cost compression. The price of AI inference, which is just generating an answer, has literally plummeted. It collapsed by over 100 times in just a few years. We went from paying around $60 per million tokens for GPT-3 in 2020 down to mere pennies in mid-2026, with models like DeepSeek V4 Flash at 28 cents. Raw intelligence is rapidly becoming a cheap commodity. But, and this is a massive but, do not let that low base cost fool you. Agentic token multiplication is a huge, shocking trap. Remember those autonomous agent loops we talked about? A single query might be cheap, right? But if your agent goes off autonomously to browse 100 websites, read a bunch of files, and write code iteratively, it multiplies those tokens thousands of times over. A simple task can easily turn into an enormous, completely unexpected API bill, sometimes hundreds of dollars in a single hour, if you don't implement strict spending caps. To navigate this without going crazy, you have to stop treating raw capability as your only metric. The dossier recommends evaluating your deployments sequentially across 4 distinct layers. Layer 1, raw capability. How smart is it? Layer 2, deployment properties. How fast is the latency and how good is its tool use? Layer 3, product UX. Does it actually integrate with your existing software? And Layer 4, total economics. What is the real cost at scale? A model can be an absolute genius at Layer 1, but completely fail your business at Layer 4. Finally, Part 5, the 2026 Playbook. Let's bring this all together into some actionable strategies for navigating the rest of the year. If you're a startup, you absolutely must build model-agnostic architectures. Hard code, no single provider, because the leaderboards literally change monthly. If you're a developer, your focus has to shift from chasing a single best model to building really great agent scaffolding, because a cheaper model with excellent tools will often beat a frontier model with poor tools. And for the enterprise, raw intelligence matters a lot less right now than governance, data residency, and ensuring your vendor isn't going to just disappear tomorrow. You also really need to design for the new types of risks, because ultimately, as we push into these autonomous workflows, your biggest operational risk is no longer a generic chatbot hallucination. It's subtle, silent errors. An agent might hallucinate a tool parameter or invent a file path out of thin air. And because it's running autonomously, that tiny error cascades catastrophically through your entire system. You have to design for failure now, not just for capability. So I want to leave you with this to chew on. As agentic scaffolding becomes the real product and open-weight models perfectly match today's state-of-the-art closed models, what happens next? Are we just witnessing a temporary parity where the closed labs are catching their breath before the next massive leap? Or is this a permanent structural shift where raw AI intelligence is officially a commodity? Let that sink in as you plan your next big build. Thanks for joining me on this explainer, and keep learning.